Welcome to Device Hacking 101, building a serverless application for an IoT device. My name is Mohib Zara. I'm a senior developer advocate on the serverless team for Amazon Web Services. A little bit about myself. I have a long background in hardware hacking, as well as development in the cloud and on hardware firmware. I've also served on the board of directors of a nonprofit hackerspace in Mesa, Arizona. And I studied at Arizona State University in Arts, Media, and Engineering. Let's get straight into why are we here. Our main objectives is to learn about IoT development devices and how to program an ESP32 Wi-Fi microcontroller to connect to AWS IoT. And we'll get a little bit more into that device towards the end. And then we're going to deploy an application from the AWS Serverless Application Repository. Now, what is serverless? You can look at serverless as really three things. You have an event source, a function, and services that function can call out to. In a typical web application, you'll have to manage servers, deploying them, managing all the routing, and all the complexities that come with that. Whereas within a serverless application, you can use, for example, AWS Lambda Functions to run small units of compute using a number of runtimes as well as available custom runtimes. And included ones include Node.js, Python, Java, C#, and so forth. An event source can be an API call to Amazon API Gateway, or it can be, say, a message on an IoT bus. There's really a huge number of event sources that you can select from, and then you can call out to all these other Amazon services, from Amazon Recognition to Amazon DynamoDB. So building an application becomes much simpler, and you can really focus on what you want to do, knowing that because you're using AWS Serverless, it's already ready to scale into a production environment. For this demo, we'll be using the AWS Serverless Application Repository. This is a collection of various Amazon-provided and community-provided serverless applications that can be deployed just through clicking and filling out a number of environment variables. It's a really powerful way to go and get right into having an application deployed. And because it's using serverless, it's already ready to go into production. A serverless application for the Serverless Application Repository is built using the Serverless Application Model, or SAM. This is an extension on CloudFormation, which is basically a syntax for defining resources that you want deployed and anything else that goes with that. With SAM, there's a number of special serverless resource types for functions, APIs, and tables, layers, and applications. And while it also supports everything that AWS CloudFormation supports, it also includes a number of policy templates that can really help build an application without getting too caught up in all the nitty-gritty specifics. This is an example of a serverless application using SAM. It creates a Lambda function as well as DynamoDB table and an IoT rule that will invoke the Lambda function whenever a message is published to an IoT topic. So if you have an IoT device that's publishing to an AWS IoT topic, that will get forwarded to this function, and then this function can do a lot more with that message. So if you have a limited device, it now has the ability to do much more in whatever runtime you choose to use for your Lambda function. AWS IoT. Now, AWS IoT Core provides an MQTT broker for publishing and subscribing to message topics. This is a open specification, this MQTT protocol, and it's used by a number of devices and services. AWS IoT Core also allows you to create secure and manage device credentials. And the rules engine allows for routing events to multiple targets, such as AWS Lambda, as well as many others, such as Kinesis and DynamoDB. This is what we're going to deploy. We're going to have our ESP32 device, which we'll talk about more in a sec, use the IoT MQTT protocol to message AWS IoT Core, where then an IoT rule will look for that topic, and then its action will be to invoke a Lambda function, the topic subscriber function. And this function will then reshape the data that comes in, because we have a very limited device sending a message up to the cloud, and we're going to want to add more data to that, or maybe repurpose it and direct it somewhere else. Then it also will deploy an Amazon API Gateway endpoint, which when posted to, will call the topic publisher Lambda function, which then publishes to an IoT topic that the device is subscribed to over the IoT MQTT protocol. Why should you connect a device to a serverless application? Well, there's so many things you can do once you've connected this device into AWS. You can create physical displays for alerts using services like Amazon CloudWatch to invoke an AWS Lambda function. You can collect sensor data and visualize and analyze it using Amazon QuickSight, or create machine learning and artificial intelligence applications using services like AWS SageMaker, and even enable language translation on edge devices using Amazon Translate. And those are just a few of the Amazon services. It really adds superpowers to your device. And we talked about this microcontroller we're going to use, and so what is a microcontroller? Well, it's an integrated circuit designed to perform specific operations in an embedded system. It typically has a processor and some memory, and it provides input and output pins for doing interactions with analog or digital devices, and sometimes other types of peripherals, such as serial buses and other specific use ports. So they come in all shapes and sizes. They can be reprogrammed, and they shouldn't be confused with things such as the Raspberry Pi or BeagleBone, which are open source single board Linux computers. A microcontroller typically isn't as powerful as a full-blown computing device. The chip that we're going to be using is the ESP32. This was created by Expressive Systems, and it's a low-cost, low-power system on a chip, or SoC. Some can be multi-core. The ESP32 in particular includes Wi-Fi and Bluetooth radios, and it's heavily supported by the open source community, and is compatible with the Arduino IDE, which is a development environment we'll be using to flash this board. Now, the history behind this board is actually quite fascinating, so I urge you to take time to research how this chip really came to be as a result of the open source hardware community. ESP32 modules come in all varieties. The chip has become so popular in the community that it's become a go-to solution for creating a very low-cost Wi-Fi or Bluetooth-enabled device. For this demo, we're going to be using the M5Stick-C. This is a low-cost ESP32-based development board created by M5Stack, and this is their smaller module, which has a number of built-in features, including a microphone, an IMU, buttons, as well as quick connect ports for sensor modules. It also has a built-in LCD, which we'll be using to display messages that are coming in from our serverless application. So let's get down to building this application. The included link will take you to a recent blog post that covers all the steps that I'll be walking through. The first thing you'll want to do is install the Arduino IDE. This is the development environment to program this chip. But you can find it at arduino.cc, and it's free to download. The beauty of this tool is, prior to the Arduino IDE, development environments for programming microcontrollers were expensive and were not unified. Usually every single chip manufacturer had their own development environment. And Arduino's really opened up this door by also creating it to be very simple. A basic Arduino application is called a sketch. So you have your sketch file, which just has a setup function and a loop function. Anything you need to do once is done in the setup function, everything else is done in the loop. And the Arduino community has created a number of open source libraries and added tons of support for various boards. We're going to need to install the support for the ESP32 modules. This includes all the things needed for the compiler toolchain, as well as pin specifications. So to do that, we'll go to GitHub. On the Expressives GitHub page, they have a repository for Arduino ESP32, and this includes instructions for the Arduino board manager, and in there is a link to their board packages. So you would need to copy that, and in Arduino, you would go to Preferences or Settings and add this URL to the additional boards manager URL. I've already installed it, but the process to do so is to then, once that link is added, to go to Tools, go to Board, and Boards Manager. And then in here, once it pulls down the whole index, type in ESP32, and you'll find this. And this includes support for everything, including the M5 stick C. And then you can install the latest version. Now, we'll need to install a couple of libraries for our sketch to work. Go to Sketch, Include Library, and Manage Libraries. Once it loads the list, type in MQTT, and there will be a library by a man named Joel Gelweiler, and you'll want to install this library. And then after selecting and installing that library, search for Arduino JSON and install the one by Benoit Blanchon. And this will allow our sketch to be able to parse and to encode and decode JSON, which we'll be receiving and sending to AWS IoT so that it can be handled by our Lambda functions. So once those libraries are installed, you'll also need the library for the M5 stick, which is not necessary for other ESP32 boards, but in this case we're going to be using the LCD definitions found in this library. So that you can also find through the library manager. Then once you've done that, on the AWS samples GitHub, we have a number of examples for using AWS IoT on ESP32 devices, and we're going to select within examples the M5 stick LCD example. And so there's two files in there, which is the INO file, which is the main sketch file, and the secrets header, which is where we'll be adding our credentials from AWS IoT when we get to that point. So go and click raw. You can also just download this whole repository and pull it from there. But I'm just going to copy and paste this into a fresh sketch file. And we'll save that as our webinar. And then here you can click this tab, this little arrow here, and create a new tab. And just name that secrets.h. Then we'll go back to the GitHub and grab that secrets file. And in here, there's a couple of things we'll have to fill in: our Wi-Fi credentials, our AWS IoT endpoint, as well as our various certificates. And once we get this all programmed, we'll walk through the code. So now we're going to want to go into the AWS Management Console. And you can create a free tier account by going to aws.amazon.com/free and type in the services IoT Core. From here, we're going to click on manage, and we're going to create a new thing. And we're going to just register a single thing. I'm going to give this an arbitrary name. We'll type in webinar. And there's a bunch of other properties here that you can attach, and this just makes it easier to organize, manage, and find your things. In this case, we can leave those blank, go to the next one, and we're going to use one-click certificate creation, and this will create all our credentials. All right, and once you get to that page, you're going to want to remember to hit activate here, and now this will make these credentials valid. So we're going to need its certificate. I'm going to save that somewhere secure. For now, it'll just go to my downloads folder. And then we're going to need its, let's see, the private key. And we'll also need the root certificate for Amazon. This is the and for this we will need root certificate authority 1. So this just opens up in the browser, and we'll copy that and we'll put that here in the secrets file. And we'll remove that space. And we want to open this with the text editor. So that was our private key. We'll add that here. And then we will add the cert. Now on some other boards, such as the Arduino MKR 1010, the Wi-Fi enabled board, it actually includes a crypto chip built in, so you can create the certificate on the device and then add it into AWS. All right, so now we have all our, now that we have our certificates and private key added into the secrets file, we want to make sure to include our thing name, which was webinar, and Wi-Fi credentials, and our AWS IoT endpoint. Let's go back to IoT Core, right? We're going to skip attaching a policy for now because there's a couple of things we need to do. And so we'll hit done now, and our device is created. So we have webinar here. And let's go back in the IoT Core console. You're going to want to click settings, and in there you'll find your AWS IoT endpoint. Let's copy that, add that to our secrets file. And we're going to use my phone as the Wi-Fi access point for this device. And I will be changing my password. All right, and now we've got all that added, right? So we have everything we need to run this example. And this example, what it's doing is it's connecting to AWS IoT, and then it's connecting as our newly created thing in IoT Core, and it's subscribing to a topic specified up here. So we have these two topics, our subscribe topic and our publish topic. The subscribe topic, ESP32/sub, is the topic that our device will be listening on. Anything published to that topic, our device will now display on the LCD. So we have this function here, the message handler, and this receives that payload and topic, displays it, and then creates a JSON object, or deserializes this JSON object, and then displays it on our LCD using the M5 stick library. And then periodically, about every second, we're going to be publishing to the published topic, ESP32/pub. So anything listening on that topic will be receiving messages from our device. All right. So now that we have all that in, we just need to add our security policy before we go ahead and flash and begin our device. Otherwise, it's just not going to connect. In Secure, under Secure on the sidebar, click on Policies and create a new policy. So we'll call this our webinar device policy. And to make this easy, we're going to click on Advanced Mode, and in that GitHub repository with the AWS samples, there is a sample policy that includes all the permissions we'll need for our device. So let's take a look at the sample policy that we grabbed from the AWS samples, IoT samples repo. In here, we want to give a couple of permissions to the IoT device. We want it to allow to connect to IoT. We want to allow it to subscribe to a specific topic, and we want to allow it to receive from a specific topic, and we also want to allow it to publish on a specific topic. You could give it, star all permissions, but this way you're locking this device down that it can only do what you tell it to do, which is publish and subscribe on these specific topics. We're going to replace some values here, so mainly our region and account ID. So region can be found up here in the AWS console. In this case, we're in US East 2. So replace all instances of that. And our account ID is your AWS account ID. So you can go into console and select My Account from the top bar. And in there you'll find your account ID. We'll replace that. And then lastly, you want to replace your thing name with the exact name that you've named your device. And if we go back to IoT Core, we can take a look at that and make sure we have that correct. Yes. And I will copy that and we'll paste it back in here and click Create. Now we've created this new policy. Now we need to attach this policy to our device. So we go back to Manage and we go to our device webinar and we go to Security, we go to Security, we click its certificate, and in here under Actions, we're going to attach a policy. And this will be the webinar device policy. Fantastic. So now our device has all the permissions it needs, and we have the credentials on the firmware. So let's go ahead and connect up our device. So this is the M5 stick. Right? Its kit also includes a watch form factor, so we'll just pop that in. So now we got a nice AWS Cloud Watch, and it uses USB-C. So I'm going to plug it into my computer. Now these different boards will require different serial drivers, so just be sure to research what driver you might be missing before trying to flash your board. And again, we made sure that we installed all the necessary libraries and board definitions. So now we'll click on Tools. We'll make sure we selected an M5 stick C under Boards. And then we'll check that we have the correct port. In this case, it's the only device I have plugged in, so I know that's the one. So it's running just sample from it right now. Now we've added all the information here, and now we can click Upload in the Arduino IDE. Now this will compile this sketch, and then it will create a binary that it can then upload to this board. So this might take a moment, but we'll see things change on this. And I'm going to make sure my hotspot is running. Alright, so now it's done uploading, and the screen will go blank for a moment until it's able to connect. And one thing we can do is click on this button here, the serial monitor, and this will tell us what's going on over USB. But right there, it has just connected to AWS IoT. So now we can interact with this device real quick using the IoT Test tool. So back in the AWS IoT console, click on Test, and we will type in for the subscription topic ESP32/pub. That's what it's publishing to. So we'll subscribe to this topic, and here we're receiving the time and a sensor value. So in this case, it's just reading off one of the analog pins, and since there's nothing connected to it, it's not really quite changing. So now we have a device that can message AWS IoT. Now we need to deploy our serverless application. So in AWS, next go to the AWS Management Console and type in Serverless Application Repository. From there, go to Public Applications and make sure that you've selected Show Apps that create custom IAM roles or resource policies, and type in Lambda-IoT rule. And then click on it. And here it'll tell you a little bit about this application. You can also go to the GitHub page, which I have open here. And it's using the SAM template that we spoke about prior. In this case, there's a lot more going on. It expects a publish topic and a subscribe topic. And then it'll create two Lambda functions, as we saw in the diagram, that one for listening for messages, and then one to publish messages when called over REST. Yeah, so here we are. For publish topic, this will be the topic to publish on. So we're going to publish on ESP32/sub, because that's the topic that our device is listening for. So we want to publish to it. And then we're subscribing to ESP32/pub. These are the messages being published by the device. Click on the acknowledgement for the IAM roles, and then click deploy. So this will take a moment, and it'll update you once it's created. And while it does that, let's go over it again. Right. So here in the template, we have our parameters, and then we have our resources, these two Lambda functions. This one has the topic subscriber has a policy permissions to publish to a table, Amazon DynamoDB table, and it also creates the IoT rule here using the subscribe topic. And then the topic publisher here has the permissions to publish on AWS IoT. In this case, we gave it permissions to publish to all topics. And then we create our table, and we also create our API endpoint. So looks like we've still got some time on that. We're looking at the AWS Lambda Console for the function topic publisher. In here, we've got a Node.js function that uses the AWS SDK to have access to the IoT methods for publishing to a topic, which was stored on an environment variable here called publish topic, which we provided when we deployed the SAR app. It receives the event that comes through, the event handler here for the Lambda function, and then passes that message on through into the params. Now, if it's being called by API gateway, it expects to find an event.body, which is where the JSON body would be stored. Since we're going to be messaging directly from the Lambda console here, we're going to remove that part that it says body, and we're going to click save up here. This saves our Lambda function. Then we're going to create a test event. You can name it whatever. And we're going to give it a key message And in here, we're going to put an arbitrary string. We'll just say hello, and click create, and then now click test. We should see that it received a message. We saw that our device received that message and displayed it on the LCD. Now, we also remember that our device was publishing that sensor value. We saw that happening in the AWS IoT Core test page. So going back to our application page here, open up the topic subscriber from this list. And this is the Lambda function that is being called by the IoT rule. So we see that here, that's its event source calling this function. And its destination is, in this case, the DynamoDB table. So if we take a look at the code here, it uses the AWS SDK again for Node.js. It's also requiring the UUID library, and it's using the environment variable for the table name, which was set automatically by within that SAM template. So here we take a look. It is taking the data that came in. So this is the message that came in from the device publishing the sensor data, and we're adding an actual timestamp. We're using date.now, so we're giving it a real timestamp. So if your device, say, didn't have a real-time clock built in, you can make sure that you're stamping your data as it's actually coming in. With some microcontrollers, time can be tricky to get correct on there. And we're creating an IDE using the UUID library and then inserting that to the database. And then if we click here on My Table back in the application, and we click on Items, we can see that we're receiving all these values. So all this sensor data has come in since we flashed this board. And now that data can be used with QuickSight to create analytic dashboards, and you can also pump that into, say, a SageMaker training endpoint and create your own machine models for various types of sensors. Within the Arduino ESP32 examples on the AWS samples GitHub, there's even an example for using a spectral sensor and publishing that data up to AWS over IoT into a Lambda function, where you could then, really clean up that data and pass it along to other services. So what we've built here is we've taken an off-the-shelf device. We use this example Arduino sketch to program it with AWS IoT credentials, secure credentials attached to a secure policy that only allows it to publish and subscribe to 2 topics. We then deployed a serverless application using the Serverless Application Repository, provided it those topics that our device is publishing and subscribing to. And then we were able to test sending a message down to this device, having it display, and also we saw that messages were being passed from AWS IoT over using the IoT rule to invoke a Lambda function, which then added metadata to the payload and then inserted that onto a database where we can do all sorts of different things with. This is really the launching point from where you would build complicated or powerful serverless applications to add new abilities and capabilities to a device. We could, for example, change this destination to go towards an SQS queue where we could have other apps consume this message and add other information to that. We could call, for example, this device, say you added a microphone to it that has a built-in microphone. You could take in audio, create a WAV file, send that to a Lambda function to then run against Amazon Translate. So really, possibilities are endless, and I really hope that this webinar has been helpful in learning the basics of programming with Arduino using an ESP32 device, and also in deploying a serverless application that can interact with IoT devices. Thank you, everybody. My name is Mohib Zar again, and my Twitter handle is VirgilVox. For more information, check out aws.amazon.com/serverless. If you have any questions, thank you.